All right, we're going to look at pages 4, 5, 6 of the P.1-P.3 review here. It says a calculator is allowed for this, although you don't technically need it for any of these, but if you'd like to use it, you're welcome to. This one tells us to write an equation for the line that goes through this point, 8, -3, so that's a key piece there, and is parallel, so that means it has the same slope as this. So the slope in this one is not directly, we have to do a little bit of work on this, so if you subtract 5x, kind of just throw that in the front and then divide by 2, we end up with a slope of -5/2. Okay, and since we're parallel, that means we have the same slope, so our slope will also be -5/2. So we have a point, we have a slope, so we're going to use that point slope form, and that's what we want to use all year long. We don't want to get silly and try doing extra work. We're just going to go y minus the y coordinate equals slope times x minus the x coordinate. Just that simple. Don't overcomplicate it. The AP will accept that full credit. On a multiple choice, maybe we have to do a little bit of work, maybe we have to distribute, but unless they ask us to, there's no reason for us to do more than we need to. Okay. Similar down here, we want to find these function values, so we're going to put -4 in there. We're going to get 2 times -4 squared minus 5. Be real careful, especially if you're using a calculator. -4 squared, -4 times -4 is 16. 16 times 2 is 32. Your calculator, if you're not careful, will make that -32, and you'll start cursing your calculator needlessly. 27 is what we end up with there. Okay. For this one, it's the same idea. We're taking 3c and putting that in for this x. So we're going to have 2 times 3c squared minus 5. Okay. Now 3c squared is 3c times 3c. That's 9c squared. And we're multiplying that by 2. So that's going to give us 18c squared minus 5. All right. So again, a little unusual, not quite just a number like this one, but that's how we do this. And this one, again, a little weird. We have 4x squared plus f of x, and you might, well, what do I do here? Well, they told us what f of x is. It's 2x squared minus 5. So we're just going to put that right for f of x. That's what it is. So 4x squared plus 2x squared minus 5. And if we combine that, we get 6x squared minus 5. So again, if you're saying, wow, that seems really simple, it is. You just have to kind of let go of some of maybe the things you were taught before that made it seem really complicated. It can be quite simple if you allow it to. All right. Next one hopefully didn't bother you. It says Charlie's got a gym. It costs $75 to join plus $35 each month. Can we write an equation? Again, this is kind of basic algebra. The cost is going to be $75 to join plus $35 per month. Okay. And if you wanted to get fancy and make this function notation, you could do C of M, but that's unnecessary. Now it says if a member had paid $1,000 up front, when would the membership run out? So 1,000 is the cost, all right, plus 35M. And if we subtract 75, we get 925 equal to 35M. And then we would divide. So take a calculator, go 925 divided by 35. And it'll give us some decimal here. I don't have my calculator with me. But whatever this ends up becoming, that's going to be your answer. Now, if you get a decimal, say you get like, 31.6 or something, you wouldn't want to round up in a case like this because you haven't paid for the full month. So you'd probably just keep it at the smaller, the whole value of that. All right. But that's going to be our answer there. This one was maybe a little unusual. It said you have a composition H inside a G, which is inside a F, and we want to try to break it down. And the reason we're doing this is for something we're going to get to in chapter 2 called chain rule. We want to be able to take a look at a function like this and say, well, what's the inside function? What is it inside of? And be able to do a derivative through there. So H is the innermost function. It's the most inside thing. And so as we look at this, the thing that I see that's inside of something else is this x squared. It's inside of this sign. So I would say that the innermost function is that x squared. And that was put inside of a function g. And if you look at this, it looks like x squared was put inside of sine. Now, we wouldn't want to just write sine. Sine by itself doesn't mean anything. It would be sine of x. And this x squared was put in place of that x right there to create the sine x squared. Okay? And then you'd say, well, what was that then put inside of to make this thing? Well, that's actually easier than you might think. It was just put inside of x plus 5. So once you put this x squared in here and made sine x squared, then you would put that in here and you would have sine x squared plus 5. And that's how we would create it. So again, we're going to practice that a whole lot, especially when we get into chapter 2 and talk about chain rule. And we're going to get real comfortable with breaking these things down. Okay. Here we got a table and it says that it's a linear equation. We want to answer some of the following. So the first question says, well, what's the slope? So in order to find the slope, we want to find, well, how is y changing? Y went from 17 to 5. That's a change of negative 12. And when it did that, the x changed by going plus 3. So slope is change in y over change in x, which is then negative 4. And we could have done any combination, really. Could have picked anything and it would have given us that negative 4 as our slope. Okay? So now if we go backwards, knowing that it's negative 4, if we kind of come back to when x was 0, we would have to go down 4 to get to 17. That means that our y-intercept must be 21. Now there's other ways you can do that. There's other forms you can take, but that's, to me, is always the easiest when I have a table. Just kind of come back to 0 and see what it is. So now that I have slope and y-intercept, I can actually make an equation. Y equals negative 4x plus 21. So then this question says, well, what is y of negative 3? Which is a function notation. It's no big deal. It means exactly what you would expect it to mean. It means go ahead and put negative 3 in for x. And so we're going to get negative 4 times negative 3 plus 21. And that's 12 plus 21, which is 33. You'll be surprised. Like this you may never have seen that before, but you had an instinct that maybe told you that. And that's what I want you to trust throughout this class is if you see something unusual, don't feel like you have to know the answer before you try. Give it a shot, see what you come up with. You'll be surprised how often your instinct takes you to a good place. All right, last thing we asked you to do is to create a piecewise function for this graph here. And we had hoped that you would assume that it was going by 2's here. If that threw you off, my apology. But this is 3 here, and this is negative 3 here. Okay? So we've got a transition at negative 3. So if I kind of set this up, our function, all right, is going to be one thing before negative 3 and then one thing after negative 3. Okay? And the thing that it is before negative 3 is this line. So I'd like to kind of get a slope off this line. This line's going down 2 over 1. Technically, it's down 4 over 2. So our slope is negative 2. Okay? And if I were to keep going there, I would get, again, there's a couple ways that you can do this. I'm trying to think of the easiest way to explain it, but what I notice is that when I put negative 3 into this equation, I get 0, right? So if I were to put negative 3 here, negative 2 times negative 3 would be 6. I want to get 0, so I would have to have negative 6 there to balance it up. Again, another way to do it would just be to continue going down and over and down and over, and then you would hit negative 6 eventually with that. Okay? Now, that one might be the easier one. You might feel a little more confident doing that, which totally get. The quadratic, I want to try to make as easy for you as possible. So we've got this quadratic that's flipped upside down. And so because it was flipped upside down, I know that it has a negative in front of the x squared. Now, whether it's a negative 1, negative 2, negative 3, we may not be so sure at this point, but we know at least it has a negative in front of there, so we'll start with that. The other thing we know is that it hit the y-axis up here at 9, so it's got a y-intercept of 9. Okay? Now, the hope would be that if I were to put 3 and negative 3 in, I get 0 right away, because then that kind of confirms that that's all it was. If I don't, then there's probably more to it, right? So if I were to put 3 in here, 3 squared is 9, negative 9 plus 9 is 0, and that's what we get. We got 0. If I put -3 in there, -3 squared is 9, -9. We end up getting it. So we get a little lucky with that. Wasn't a whole lot more to it. Now, the AP is not going to try to bust you on something like this. That they only have so much time, and they're really trying to see if you understand calculus. So they would be more interested in, do you just have a general idea of, how quadratics work, rather than the deep intricacies that you probably got into in pre-calc or maybe algebra 2. All right. So hopefully that feels good there. If not, practice some more of that before our quiz, but I'm sure you'll do fine.